Okay, so since I'm not there in front of you and talking to you on Zoom lessons aren't good, I'm going to do it like I would do it if I was in school. So I'm going to explain to you how I'm going in school so maybe it's a little bit more understanding. So let's go back, and we just finished looking at the video where I said subtraction doesn't really exist in integers because you don't subtract. Subtraction doesn't exist. It's always becoming addition. Well, let's prove why. And we need to understand how one equation can look three different ways because right now we have parentheses around our second value. That's not always going to be. Eventually, that's going to be where you're not going to see the parentheses, and it's just going to be one big equation. And you have to understand how that is. You can't just know, oh, I changed this and I do that. You have to know the real reason behind everything. So I'm going to show you here. So now I'm going to draw my negative 4, 1, 2, 3, 4, and my positive 6. 1, 2, 3, 4, 5, 6. Now this is a simple addition problem, so I really don't need to, oh, I messed it up. I'm supposed to draw negatives. See, so again, this is, as I'm erasing this is an addition problem, so we really don't need to change anything, right? Because now I have 1, 2, 3, 4, 5, 6, and everything's the same. We're going to add up. But I want you to see how this can be expressed. This exact same equation can be expressed as a subtraction sign. So this equation really, as we get bigger and smarter in our pre-algebra lessons, should be really written negative 4, negative 6. That's the exact same thing. So I'm adding negative 4 and negative 6. That is equal to that. And this equation is really negative 4 minus a positive 6. That equation is equal to that too. So this equation is equal to this equation is equal to that equation. Every one of these is the exact same thing with an answer of a negative 10. Because remember what we just saw, we can't subtract negative from anything. So let's just draw my negative 4 here. Let me draw my positive 6 here. Now I'm supposed to be subtracting positive 6 from negative 4. I have a basket. Someone comes over and takes the last 4 apples in that basket. Now there are no apples in that basket, so it's 0. So now how am I going to come and take more from something that does not exist? So I have a basket with negative 4 apples. Yeah, I don't know. I've never heard about negative 4 apples, so you don't do it. So for your second value, in order to change this into this, you need to change this. So to do that, you have to zero it out. So I'm going to bring in my opposites. Okay, that makes these guys go bye-bye, which makes this become a plus, makes this become a negative. So now this is, which is, all of those are the same, and I get a negative 10. So this is why you don't really say ever subtraction. Because when we stop looking at, see right now they're writing everything with parentheses, and it's nice and pretty. But this here does not really mean, like, let me write it bigger here. Negative 4, negative 6 does not mean negative 4 minus 6. Okay? Because minus is an operation. The negative sign is a negative sign, so that is expressing negative. So when you say negative 4 minus 6, you're really saying negative 4 minus positive 6 when you use it as a negative. But if you read it as negative 4, negative 6, you're really saying negative 4 plus negative 6. Okay, now it could be confusing. So that is why I always stress, and I always want to make sure the students understand that this expression, and that this expression all are the same thing. Okay, as we see here. Okay, let's look at the next one. So we have 5 minus negative 3. Here I would say minus because that means that negative goes with that number. So 5 minus negative 3. So I'll have 5 and I'm going to take a negative 3 away from it. That is not a value. I can't go, hey, Mom, can I have negative $3? My mom would be like, yeah, sure. That means you get nothing. Oh, okay. So let's draw it out. So here's my 5. 1, 2, 3, 4, 5. And here's my negative. Okay, I'm taking negative $3. So I need to change that. But I can't just go and change it without really knowing why. So in order to change that, I'm going to bring in 3 positives. Woohoo! By getting those 3 positives, I zero them out. These are opposites. And by zeroing them out, I change this entire equation to 5 plus positive 3. Okay? And by doing that, notice I change that, I really have 5 plus 3, which is equal to 8. And we have 8 circles here. Okay, so let's look at this again. 5 minus negative 3 can't do. Doesn't exist. Not a real expression. 5 plus positive 3, when I get rid of my negative 3 by zeroing them out, I have to change that sign because I'm doing the opposite, and now I have 3. 5 plus 3 equals 8. So 5 minus negative 3, 5 plus positive 3, and 5 plus 3 all mean the same thing in the sense that it gives you the same answer. It's just different ways of looking at it. Try not to get used to seeing minus a negative 3 because minus negative 3 is really 5 plus positive 3. Let's look at another one. Okay. Negative 2 minus negative 7. Now I really have nothing, and I'm taking more away from nothing. You take nothing and take more from nothing, you're left with super duper large amount of nothing, which means nothing. So here's my negative 2. 1, 2, 3, 4, 5, 6, 7. There's my negative 7. Okay, guys, take it away. You can't. You can't minus. You can't subtract. So I'm going to bring in my positive. 1, 2, 3, 4, 5, 6, 7. Change that to by. Make that a plus, which becomes negative 2 plus positive 7. But we want to get practice, and we want to get big, and we don't want to always write our numbers with parentheses. It's a lot of writing, and in algebra, they don't do that. So I like to stress it now. If you're more comfortable writing like this, absolutely, positively do that. That is nothing wrong with that. I'm just showing you the next step. So that really is negative 2, positive 7, which is going to give me a 5. Okay? And if you look here, we have 7, we have 2, because now I'm adding it. Remember, I changed this to this. I can zero them out, and I'm left with positive 5. Okay, one more. Negative 8 minus positive 3. Okay, I got negative $8. I'm going to take positive 3 from it. No, you're not, because negative 8 is so small. But I'm going to draw it 1, 2, 3, 4, 5, 6, 7, 8, and then do my positive 3. All right, so that's nothing. That's less than 0, but I'm going to take 3 from that. No, you're not. You're going to change everything. So I'm going to bring in my negative, get rid of that, and my new equation now is negative 8 plus negative 3. Now I can do everything. I can add it up. I can write it like big kids, negative 8, negative 3, and my answer is negative 11. Okay? Now, most of the books that you read and most things will tell you that when you are subtracting integers, yes, I'm going to use that word now because they do refer to it as subtracting because you are changing the whole equation. I am changing that to an addition problem. You do change to addition. And then you do change the sign. Okay, that's what we did. In essence, that's what we did each time. We changed to addition and changed the sign. Change to addition and change the sign. But why? Why? Because you cannot subtract negatives. You cannot subtract integers. You cannot take a negative and a positive and subtract it. You cannot take a positive and a negative and subtract. Now, you might be saying, well, what if they're the same signs? Well, let's look at this one up here. These two are exactly the same sign. They're both negatives. But I'm not subtracting negatives. I can't take negative 2 minus a negative 7. It just can't be done. You can't take negative from nothing. So that's when you see that you have a negative 2 and a positive 7. Now, I want to show you another example that I just thought of right now. Okay, so let's say we have, okay, this is what we've been doing from the beginning. Let's say we have 5 minus a positive 3. Okay? What? Yeah, but now I'm